Hi all. In this video, we're going to talk about value at risk and how to calculate it. So first of all, what is value at risk? Value at risk is an important concept in risk management. Value at risk is a measure of how much an investment portfolio could lose over a certain period of time. There are three variables related to value at risk that are important. One, the amount of potential loss. Two, the probability of losing a specific amount. Three, the time period of the analysis. There are several widely used methods of computing value at risk, including first, historical method, which uses the historical return data to calculate the likely amount of loss over a certain period. Two is the variance covariance method, assuming that returns are normally distributed and using the mean and standard deviation of historical returns to compute the value at risk. Three, Monte Carlo simulation, constructing a model to project potential returns and run multiple trials to get the value at risk. So some takeaways. First, all assets carry risk, interest rate risk, market risk, liquidity risk, etc. Two, diversification with multiple uncorrelated assets could reduce value at risk, mainly by reducing the portfolio standard deviation. Three, the three common methods of calculating value at risk could yield different results. There are two other related concepts. The first is marginal value at risk, a measure of how much risk an additional investment adds to the portfolio. This measure is dependent on not only the inherent risk of the asset, but also its correlation with other assets in the portfolio. Two, conditional value at risk, a measure of extreme loss that exceeds the value at risk point in a probability distribution for projected returns. And then finally, this is the code that you can use, the Python code that you can use to calculate value at risk. First, what you want to do is you want to calculate the daily value at risk, and this is the function that defines it. You want to import SciPy from SciPy.stats, import norm. All right, and then you calculate this function, which is the daily value at risk. Then you import NumPy as NP, and then you have a portfolio, let's say, of $100 million, and you have confidence of 95%. So, how much could you lose, in sort of a 5% type of event. And then the daily returns are your daily returns for whatever the asset is. And then this is basically the prices with the percent change. And then mu is the mean of your daily returns, and sigma is the daily standard deviation of your daily returns. And then you just take value at risk, you use the calculate daily at risk function, use your portfolio, which is 100 million, use your confidence, which is 95%. And then you have mu, which is, again, the average return for your daily returns. Sigma is your daily standard deviation, and then days per year, 252. And then this is going to give you, your 95% confidence value at risk, which is basically, this means 95% of the time, this is the amount that you could lose or less. Anyway, I hope you found this video helpful. The purpose of this video is to give you a sense of if you're running a strategy and you think your returns are somewhat normally distributed, which is a big assumption. The question is, how much could you lose? What would you lose 95% of the time in a day? All right, thanks, and I hope you found this helpful, and I'll see you in the next video.